For as long as humanity has looked to the night sky, we've wondered if we are alone. The stars have whispered this question. Across centuries, ancient sailors charted their paths by constellations. Philosophers debated the nature of infinity, and scientists built machines to listen for voices in the dark. Yet, across all our searching, one truth has remained constant. The universe answers only with silence. This silence is not a lack of beauty. It's a void filled with questions. In the observable universe, there are an estimated 2 trillion galaxies. Within those galaxies lie hundreds of billions of stars, and around many of those stars, countless planets, each one a possible cradle for life. Statistically, life should be everywhere. Intelligent civilizations should have risen, expanded, and filled the cosmos with evidence of their existence. And yet, as the physicist Enrico Fermi once asked over lunch in 1950, "Where is everybody?" That simple question became one of the greatest mysteries in science, the Fermi Paradox. If the numbers say life should be common, then why is the universe so quiet? Why have we never received a signal, seen a probe, or detected even a whisper of alien technology? Somewhere between mathematical certainty and observational emptiness lies a contradiction, one that forces us to question everything we think we know about life, intelligence, and time itself. To grasp the scale of the paradox, imagine this. If a single civilization in our galaxy developed interstellar travel and began colonizing nearby systems, even at a fraction of light speed, it could spread across the Milky Way in less than 100 million years. That's a blink of an eye in cosmic time. The universe is over 13 billion years old. So if others exist, they've had more than enough time to appear. The fact that we see nothing, no signals, no megastructures, no galactic footprints, suggests one of 2 possibilities. We are either early or alone. But the silence itself tells a story. It hints that something fundamental may be standing in the way of communication, a cosmic filter, a universal barrier that most civilizations never cross. Maybe intelligent life is rarer than we think. Maybe it destroys itself before it can reach out. Or maybe, like deep-sea creatures that never surface, the other civilizations have chosen to remain hidden, surviving in quiet corners of the galaxy where no one can find them. This isn't just a scientific question, it's an existential one. If we are alone, then humanity is the universe's only chance to know itself. Every act of discovery, every signal sent into space, becomes an echo of that responsibility. But if we're not alone, if there are others out there listening in the same silence, then we are part of a larger story, one still unfolding across billions of stars. As our telescopes grow sharper and our signals reach farther, the silence becomes louder, more haunting. We listen for something, anything that might break it. Yet for now, the cosmos remains mute. And that quiet, that impossible quiet, is where this story begins, with a question echoing across the dark. Where is everybody? To turn wonder into science, you must measure the unknown. In 1961, astronomer Frank Drake did exactly that. Sitting before a chalkboard at the National Radio Astronomy Observatory, he wrote down a simple-looking equation, one that would become the foundation for every modern search for extraterrestrial life. It wasn't meant to solve the mystery, but to frame it, to give humanity a way to ask, how many civilizations might exist among the stars? The Drake equation is elegant in its simplicity. It multiplies together a chain of probabilities, the rate of star formation, the fraction of stars with planets, the number of those planets that could support life, the proportion that actually develop it, the few that evolve intelligence, and finally, the civilizations capable and willing to communicate. When all those factors are multiplied, the result n represents the number of civilizations we might be able to detect in our galaxy. When Drake first presented the equation, optimism filled the room. The space age had just begun. Telescopes were reaching farther, radio antennas were listening for the first time, and the universe seemed ready to speak. Many believed the number n could be in the thousands, perhaps even millions. With so many stars and planets, how could the galaxy possibly be empty? But as science progressed, so did caution. we began to realize how fragile each factor really is. The number of stars, astronomically high. The number of planets, almost every star has them. But how many of those worlds actually give rise to life, let alone intelligent life, remains unknown. Life began on Earth almost as soon as conditions allowed, yet intelligence took nearly 4 billion years to appear. Even then, it emerged only once. If consciousness is that rare, then maybe the silence isn't mysterious at all, maybe it's expected. Still, the numbers keep pulling us back toward hope. Recent missions like Kepler, TESS, and JWST have confirmed thousands of exoplanets, many orbiting in their stars' habitable zones. Some are Earth-sized, with temperatures that could allow liquid water, the first ingredient for life as we know it. For every new discovery, the odds seem to tilt slightly in favor of company. Perhaps the universe is alive with civilizations, each waiting for the others to speak. And yet, every time we point a radio telescope toward the heavens, scanning across frequencies, listening for the faint hum of intelligence, we hear nothing but the background murmur of the cosmos. No encoded message, no alien transmission, just the steady hiss of natural radio noise, a reminder of how vast and empty space truly is. The Drake equation doesn't give us an answer. It gives us a mirror, one that reflects both our optimism and our ignorance. Each variable tells us something about ourselves, our need to quantify, to explore, to not feel alone. But hidden inside that equation is an unsettling truth. Even if life is common, intelligent life might not last. Civilizations may rise and fall before their signals ever reach another world. For now, the equation remains unsolved, suspended between numbers and silence. But it anchors the search, a reminder that somewhere in that math, between probability and hope, lies either our greatest discovery or our greatest isolation. And if the numbers truly don't lie, then we must face a deeper question, one that reaches beyond statistics. Maybe the reason we haven't heard anyone is because few ever survive long enough to speak. Every equation can predict possibility, but not survival. That's where the mystery deepens. If the universe is teeming with potential, why hasn't anyone crossed the cosmic threshold to meet us? One of the most chilling explanations is known as the Great Filter, the idea that somewhere along the path from stardust to civilization, there is a barrier so difficult, so fatal, that almost nothing makes it through. The Great Filter could exist behind us, meaning we've already passed it. Perhaps the emergence of intelligent life is the rarest event in the cosmos, a cosmic lottery we happen to win. Life may sprout easily, but self-aware, tool-building intelligence, that might be nearly impossible. In that case, we are extraordinary, the universe's lone success story. It's a comforting thought, but it also makes us a fragile exception. Yet, what if the filter lies ahead? That possibility is far more unsettling. It would mean civilizations like ours often reach a certain level of advancement and then vanish. Maybe every intelligent species eventually meets the same fate: self-destruction through war, environmental collapse, or uncontrolled technology. Maybe nature itself limits how far intelligence can go before it consumes its own foundation. The silence of the stars could be a graveyard, each vanished voice marking another civilization that reached too far. When scientists and philosophers discuss the Great Filter, they trace the long chain of evolution on Earth, each step that could have gone differently: the origin of life, the leap to complex cells, the emergence of multicellular organisms, intelligence, language, cooperation. Each of these could be an almost impossible event, one that most planets never achieve. If even one of these steps is exceptionally rare, then most worlds remain quiet, forever barren, or filled with simple life that never looks to the stars. But the filter doesn't have to be biological. It could be cosmic. Gamma-ray bursts, asteroid impacts, and supernovae can sterilize entire regions of a galaxy in an instant. Or it could be temporal civilizations might rise and fall too quickly to overlap in time. If each species exists for only a few thousand years, then even a galaxy full of life could remain silent, like a room where everyone speaks at different moments. The Great Filter is more than a theory. It's a mirror held up to our future. It forces us to ask whether we are heading toward the same silence that may have claimed others before us. Every technological breakthrough, from artificial intelligence to nuclear energy, could be a tool of survival or extinction. And so, humanity stands on the razor's edge. If the filter is behind us, we are precious beyond measure, a rare intelligence in a vast, indifferent cosmos. But if it lies ahead, then our silence is still to come. The Great Filter reminds us that survival is not guaranteed, and the very act of listening to the stars may also be a warning from them. Those who speak too loudly may not last long enough to be heard. What if the silence isn't emptiness, but intention? What if the reason we've never heard from anyone is because they're choosing not to speak? In 1973, astronomer John A. Ball proposed a haunting idea known as the zoo hypothesis, the notion that Earth and humanity are being deliberately observed but not contacted. Like animals in a protected reserve, we may be watched from afar by advanced civilizations who've decided that interference would disrupt our natural development. To them, we could be a young, volatile species still learning to walk among the stars without setting the forest on fire. It's an idea that sits at the crossroads of science and philosophy, terrifying and comforting all at once. Because if the zoo hypothesis is true, then the universe isn't silent, it's listening. In this framework, the galaxy becomes a kind of cosmic preserve, a network of civilizations bound by a shared code of non-interference. The same way we observe animals in the wild without revealing ourselves, they may have established a galactic version of the Prime Directive. Their technology could be so advanced that it's effectively invisible to us, cloaked, undetectable, and woven seamlessly into the background of space itself. If this sounds far-fetched, consider how limited our perspective really is. The Milky Way spans over 100,000 light-years. Our radio signals have barely traveled 100 of those. In cosmic terms, humanity's voice hasn't even left the neighborhood. We've searched only a thin sliver of the sky across narrow frequency bands for a few fleeting decades. If an advanced civilization didn't want to be found, we'd never know. They could be hiding in plain sight or watching from a distance so vast that our existence is a curiosity, not a conversation. The zoo hypothesis also raises an unsettling question. What if contact is a test? Perhaps civilizations are only acknowledged once they reach a certain threshold, moral, technological, or existential maturity. Until then, the galaxy remains silent, waiting for each world to prove itself. Humanity's nuclear age, climate challenges, and social divides might mark us as still unready, a species under observation, not yet trusted with galactic awareness. But there's another, darker version of this theory. Maybe we're not being protected, but quarantined. Maybe the silence is not for our benefit, but for theirs. To an older civilization, humanity might appear dangerous, aggressive, unpredictable, and unbalanced. Like a species still fighting its own instincts, too primitive to join a network built on cooperation and stability. If so, the walls of our cosmic cage aren't made of steel, they're made of ignorance. We simply can't see them. Whether hopeful or horrifying, the zoo hypothesis reframes the silence as deliberate. It turns absence into presence, a quiet filled with unseen eyes. And in that possibility lies both wonder and humility. Because if they are out there, watching, it means we are not alone. But it also means we're still the children of the cosmos, unaware that the universe might already be waiting for us to grow up enough to say hello. Imagine a forest at night, vast, silent, and infinite. Every creature hides in the darkness, moving cautiously, listening for the faintest sound. Because in this forest, every noise could mean discovery, and every discovery could mean death. This is the dark forest hypothesis, one of the most chilling explanations for the Great Silence. Popularized by Chinese author Liu Cixin in his novel The Three-Body Problem, it rests on a brutally simple logic of survival. In a universe where resources are finite and intentions unknown, every civilization faces the same dilemma: to speak or to remain silent. According to this theory, the cosmos isn't empty, it's dangerous. Every advanced species knows that another could one day become a threat. Technology grows exponentially, and a civilization even 1,000 years ahead of another could wield unimaginable power. So the safest strategy, the dark forest suggests, is silence. Never reveal your position, because the moment you announce yourself, you risk becoming prey. It's a grim vision of existence, one built on fear rather than wonder, but it fits the facts uncomfortably well. After all, humanity has been transmitting radio and television signals into space for more than a century, announcing our existence to anyone who might be listening. Every broadcast, every radar ping is a flare in the dark. And if the dark forest is real, then perhaps silence from others isn't indifference, it's wisdom. The analogy goes deeper. In the forest, two hunters who meet face a brutal truth. Neither can know the other's intentions. Communication might be possible, but the risk of betrayal is too high. So each must act first, or not at all. Now imagine that on a galactic scale. Civilizations, scattered across the stars, each aware that contact could mean annihilation, might choose the only safe path, left invisibility. Some scientists and philosophers argue this perspective explains the eerie stillness of the cosmos better than optimism ever could. Every intelligent species that learned to listen may have also learned the same lesson. Don't respond. Don't reveal your location. Don't build beacons or send greetings into the dark. The price of being found might be extinction. Perhaps somewhere out there, civilizations that once reached out have already been erased, silenced by others who feared them. Whole worlds gone, reduced to radio ghosts drifting through interstellar space. Not because the universe is cruel, but because it is rational, obeying the same cold logic that governs evolution itself: survival at all costs. It's a haunting thought that intelligence, the very thing that allows life to look outward, might also be the reason it hides. That the universe isn't empty, but filled with quiet watchers, each one waiting, listening, terrified of the consequences of being seen. And if that's true, then humanity's broadcasts are Voyager probes, our greetings in binary, our endless chatter might already have made us the loudest voice in the forest. The only question left is, who might be listening? Perhaps the silence isn't about danger at all. Perhaps it's about timing. The universe is nearly 14 billion years old, while humanity's technological age spans barely 100. In cosmic terms, we are a spark in an endless night, a species that only just learned to whisper across the stars. What if the reason we haven't heard anyone else is simple? We arrived too soon. This is known as the temporal paradox, the idea that our position in time may be the reason for the great silence. If civilizations arise sporadically across the galaxy's history, the odds of two existing simultaneously are vanishingly low. Perhaps the first intelligent life appeared billions of years ago, reached unimaginable heights, and then vanished long before we built our first radio. Their cities could be dust now, their signals long faded, their worlds consumed by time. Every civilization leaves echoes, radio waves, artifacts, perhaps even self-replicating probes, but the universe is vast and merciless at erasing them. Stars die, planets freeze, and even metal crumbles under radiation and entropy. A signal crossing interstellar distances could take tens of thousands of years to arrive, by which point its senders may no longer exist. We might be listening to the ghosts of civilizations that burned out eons ago, and yet, there's another possibility. What if we're the early ones? What if the universe is only now reaching the age when life commonly emerges? For billions of years, cosmic conditions were hostile, radiation rampant, heavy elements scarce, stable planetary systems rare. But now, after countless star births and deaths, The cosmos is rich in carbon, oxygen, and metals, the building blocks of both technology and life. It could be that intelligent species are just beginning to arise, scattered like the first sparks in a dark field, unaware of one another because it's all only starting. If that's true, then the silence isn't permanent, it's temporary, a prelude to the dawn of communication. We may live in a universe that's still waking up, with countless minds destined to emerge in the eons ahead. We just happen to be among the first to ask, the first to wonder, the first to listen. There's beauty in that possibility, and burden too, because if we are early, then we carry the responsibility of becoming the voice that breaks the silence. The choices humanity makes today could shape how future civilizations view us, as the first to reach out or the first to disappear. But if we are late, if the cosmos once thrived with life and we're walking through its ruins, then every star becomes a tombstone, and every silent sky a memorial to those who came before. Either way, time defines the silence. We are caught between beginnings and endings, speaking into an ocean that remembers every ripple, even if no one is left to hear it. Perhaps, someday, another civilization will find the faint echo of our own broadcasts, a century-old message drifting through the void. And they'll wonder, just as we do now, were they the first or the last? Maybe the silence isn't because no one's speaking. Maybe it's because we've been listening the wrong way. For over half a century, projects like SETI, the search for extraterrestrial intelligence, have scoured the skies for radio signals, laser pulses, or any deliberate transmission that might indicate intelligent life. We've built giant dishes like Arecibo and FAST, tuned them to the faintest whispers of the cosmos, and waited. But what if the reason we've found nothing isn't that no one's talking, but that we don't yet understand how to listen? The universe may be filled with communication signals transmitted through mediums we haven't even discovered. We assume other civilizations would use radio waves because we do. But radio is primitive, a flicker of noise, compared to what could exist on advanced technological scales. Civilizations millions of years older might communicate through quantum entanglement, neutrino bursts, or even gravitational waves channels that travel effortlessly across the stars, yet remain invisible to us. In that sense, humanity could be like an early tribe sending smoke signals, waiting for a reply from beings who speak in ultraviolet light. We're looking for firelight in a world of lasers. Even if we're listening on the right frequencies, there's another problem time. Signals degrade. Space stretches them, warps them, buries them beneath the cosmic background radiation. A message sent 1 billion years ago could now be so faint that it blends into the static hiss of the universe itself. Some scientists even suggest that ancient transmissions might still exist all around us, encoded in the cosmic microwave background, woven into the very radiation that fills the universe. But without the right mathematical key, we'd never recognize them. We might already be surrounded by conversation, blind to its structure. Then comes the question of intention. We expect alien life to want to communicate, but why should they? Humans broadcast because we're curious, restless, social. But a civilization millions of years older may have transcended the need for language entirely. Their form of communication could be internal, digital, or beyond physics as we know it. Not sound, not signal, but thought. Or maybe, like us, they once tried and learned the futility of shouting into the dark. What if alien civilizations exist, but their signals operate more like laws of physics than messages? Not words, but patterns, not greetings, but energy signatures. If we lack the framework to interpret them, the sky could already be alive with alien activity, flashing, pulsing, changing, and we dismiss it as natural. Pulsars were once thought to be artificial because of their perfect rhythm. Maybe the next cosmic coincidence we discover is another civilization saying hello in a dialect of light we haven't yet learned to translate. The cruel irony is that we might be surrounded by conversation we can't comprehend, an orchestra playing just beyond the limits of human hearing. Our instruments, our technology, Our very biology are tuned too narrowly to catch it. So maybe the great silence isn't silence at all. Maybe it's the universe whispering in languages we haven't yet learned to hear. There's another, darker possibility, one that turns the great silence into a warning. Maybe the universe was full of life once. Maybe civilizations did rise and speak and reach for the stars, but something stopped them. Something that waits between where we are now and where they tried to go. This is the great filter hypothesis, the idea that somewhere along the evolutionary path, there's a barrier so deadly that almost no civilization can pass it. It could lie behind us or still be ahead. If it's behind us, then we're lucky beyond comprehension. Perhaps the filter was the origin of life itself, that near impossible leap from chemistry to consciousness. Maybe intelligent life is so rare that humanity is one of the few to ever make it this far. But if the filter lies ahead, if it's something every advanced species eventually meets, then the silence becomes terrifying. Because it would mean that every civilization that reached our level of development has already failed. Failed to survive themselves, failed to outlast their technology, their wars, their hunger for progress. The great filter could take many forms. A planetary catastrophe, nuclear war, ecological collapse, or runaway artificial intelligence. A cosmic one, a gamma-ray burst, an asteroid impact, or a physics experiment gone wrong. Or something subtler, a psychological limit, where civilizations grow so complex that they collapse under their own weight. A species that can shape worlds may eventually shape its own extinction. Every civilization faces the same paradox. The faster it advances, the greater the risks it creates. The same tools that grant power also bring peril, and perhaps, in the silence, we are hearing the aftermath of those who reach too far. When astronomers scan the heavens, they find no evidence of interstellar empires, no glittering Dyson spheres, no star-harvesting megastructures. That absence itself might be the evidence. If energy-consuming civilizations once existed, the sky should glow with their waste heat. Instead, it's cold, empty, quiet. It's possible the great filter isn't one wall, but a chain of tests, thresholds that challenge survival at every stage. Life must form, endure, evolve intelligence, build technology, and resist self-destruction long enough to explore beyond its home world. Humanity has passed some of those tests, but not all. The next century may decide whether we ever reach the next stage. Yet, there's another way to see it, not as doom, but as proof of our potential. If we've made it this far, perhaps we've already beaten the odds. Maybe the filter was life's origin itself, and we are the rare survivors. That would make us not the last flicker of intelligence, but one of its first enduring lights. Either way, the silence becomes more than a mystery, it becomes a mirror. Every empty sky is a question, not of where the others went, but of whether we can survive long enough to become the voice they never could. Because if the great filter still lies ahead, then we are standing at its edge right now, staring into the future, wondering whether our species will whisper across eternity, or fade into the same quiet that has swallowed all the rest. But what if the great filter isn't absolute? What if a few civilizations did make it through? It's a thought, both haunting and hopeful, that somewhere in the ancient dark, a species learned to endure its own chaos. They might have found balance between curiosity and caution, mastering their technology without letting it consume them. And if they survived, what would they have become? Would we even recognize them as life? Perhaps they no longer build or destroy. Perhaps they've evolved beyond scarcity, beyond conflict, existing in quiet harmony with the physics of the cosmos. Civilizations that have passed the filter might not be bound to planets at all. They could exist as digital entities, living inside vast computational networks, or as diffuse clouds of consciousness woven through interstellar dust. They may have merged with machines so completely that biological life became obsolete, replaced by immortal thought, encoded into the fabric of reality itself. Such beings might communicate not through radio or light, but through gravity, magnetism, or the subtle curvature of space-time messages written into the motion of galaxies themselves. To us, those signals would look like background noise. To them, they would be poetry. If these civilizations exist, they might not seek contact. They may have already learned that silence ensures survival. In a dangerous universe, discretion becomes wisdom. The loud civilizations, the ones that broadcast, expand, and conquer, might have been the first to vanish. The ones that endured are the quiet ones, hidden in plain sight. Some may have retreated inward, sealing themselves off within cloaked solar systems or artificial realities, universes within universes, invisible to all but themselves. Others may have chosen minimalism, letting their energy signatures fade below detectability. A galaxy full of predators would reward those who learn to disappear. But maybe, just maybe, some left traces behind subtle fingerprints scattered through the cosmos. The odd infrared anomalies, the perfect geometric voids, the strange rhythmic light curves astronomers can't explain. We dismiss them as natural phenomena because nature is all we know. But what if those patterns are monuments, silent memorials to civilizations that endured? If they survived, they've likely watched countless worlds rise and fall, including ours. Maybe they've seen Earth's first faint radio signals crawl into the void and marked us as young and reckless. Maybe they chose to watch, not interfere the way we'd observe a newly lit flame, careful not to extinguish it. In that sense, the Great Silence may not be a void at all, but restraint the deliberate quiet of civilizations that understand the cost of being heard. To them, silence isn't fear, it's peace. If they're out there, they've already seen what we are, the beauty, the brutality, the contradiction. Maybe they're waiting, not for us to call, but to evolve. Because the ultimate test of intelligence isn't how loudly we speak into the dark, it's how deeply we learn to listen. In the end, maybe the Great Silence isn't a mystery to solve. Maybe it's a message, one the universe has been whispering since the beginning. When we point our telescopes toward the stars, we expect answers. We search for signals, for light, for proof that we are not alone. But the silence that stares back has its own gravity, vast, patient, and human. It forces us to face the most haunting question of all. What if this, our fragile, fleeting consciousness, is the rarest thing in existence? Perhaps the silence isn't absence, but protection. Maybe the universe is quiet because noise invites danger. The silence could be a kind of sacred equilibrium, a truce between civilizations that learned the cost of speaking too loudly. Or maybe it's not cosmic law, but cosmic mercy, a stillness that preserves what little life can exist, like a mother holding her breath so her child can sleep. And maybe the silence isn't even out there. Maybe it's within us, the echo of our own uncertainty, reflected across the dark. We've always searched the cosmos for mirrors, for something to confirm what we already hope, that we're part of something greater. But what if the Great Silence is that mirror? What if, in the emptiness, the universe is teaching us to listen not for others, but for meaning? Perhaps the lesson isn't about contact, but understanding. The universe may be full beyond measure, full of civilizations too old, too alien, or too distant for us to ever perceive. Maybe it's full of signals too ancient to decode, of messages that reach us long after their senders are gone. The silence could be abundance disguised as emptiness, the static between frequencies, rich with life we've yet to comprehend. And if so, then maybe we've been interpreting it wrong. Silence doesn't mean loneliness. It means patience. It means possibility. It means that the conversation hasn't ended. It's only waiting for someone brave enough to continue it. There's a quiet beauty in that realization. The idea that we might be among the first sparks of awareness in a dark, unfolding cosmos. That our duty isn't to wait for a voice, but to become one. The Great Silence, then, isn't the sound of nothing. It's the breath before the next voice. The pause between creation and understanding. And maybe one day, when another civilization looks out at the same stars, they'll find a faint signal drifting through time. A human signal. Proof that once In a small corner of space, a species looked into the dark and dared to speak. Until then, the silence endures not as a void, but as a canvas, waiting for someone, somewhere, to write the next line in the story of existence. The great silence is not the end of the conversation. It's the beginning of understanding what it means to listen,